Hi guys, Mrs. Schneider here. We're going to take notes now on lesson 14.3, and this is about angle relationships. I hope you guys are doing good and hanging in there with all of this. There's a lot of information in this lesson, so hang in there with me, okay? If I can even get the title written here. Okay, there we go. So the first type of angles that we're going to talk about are vertical angles. They are formed by two lines intersecting. So these would be vertical angles. When two lines intersect, they form four angles. And you will often see these four angles named this way, with small little numbers written inside of them. And that's not uncommon to see angles named that way. It's another way to name an angle instead of using the three letters. So if we're talking about vertical angles are angles that are directly across from each other. So like in this picture, angle 1 and angle 3 are vertical angles. They share a common vertex and they are opposite each other. Another pair of vertical angles would be angle 2 and angle 4 because they are directly across from each other and they share this common vertex. One important thing about vertical angles is that vertical angles have equal measures. So vertical angles have equal measures. And when we say that in geometry, when we talk about things having equal measures, we say that they are congruent. And you will hear that word a lot. Whenever you hear congruent, it just means the measures are the same. Another type of angle relationship that we'll talk about here are adjacent angles. Adjacent, when you hear that word, it typically means next to. So adjacent angles are two angles that are next to each other. So if we have this angle here and we call it angle MNO, and then we have another ray coming out of point N, we just formed two angles. So we have angle MNO, which is this angle right here. And then we also have angle ONP, which is this angle right here. So angle MNO and angle ONP are adjacent angles. And they have this common ray or side. That's what they have in common, and this common vertex. And that's how you know that they are adjacent angles or next to each other. Another type of angle relationships are complementary angles. Complementary angles are angles whose measures add up to 90 degrees. So if we had an angle here that measured 30 degrees, and say this is angle MNO, and we had another angle over here that measured 60 degrees, say this is angle PQR, then we would say that these two angles are complementary because their measures, 30 plus 60, is equal to 90. We can also talk about another angle relationship, and that is supplementary angles. Supplementary angles are angles whose measure add up to 180 degrees. So again, if we had two angles, say we have this angle here, again this is obtuse because it opens greater than 90. So this is angle DEF, and it has a measure of 120 degrees. And then we have a smaller angle over here. Let's say this is angle CAT, angle CAT, and this is measure 60 degrees. Then we would say that these two angles are supplementary because 120 plus 60 degrees is equal to 180 degrees. So any two angles whose measures equal 180 are supplementary angles. Another example that you might see as a problem to do in your workbook might look something like this. There's a lot going on in this picture, so you have to look close at what you're being told and what's drawn here. So let's see, this could be line AB. And then we're going to name these angles by little numbers. So that's angle 1, this is 2, this is 3, this angle over here is 4, and this one is 5. So if we want to name a pair of vertical angles, remember vertical angles are directly across from each other and they share a common vertex. So a pair of vertical angles here would be angle 1 and 4. They are directly across from each other and they share that common vertex, and they are formed by two lines intersecting. If we want to name a pair of adjacent angles, again, adjacent angles are angles who share a common side and a common vertex. We have lots of pairs of adjacent angles. We have angle 1 and angle 2. They share this common side. We have angle 2 and angle 3. They share this common side. Angle 3 and angle 4. Angle 4. They share this common side. We could have two more pairs, angle 4 and angle 5. They share this side. And then finally, we forgot my angle symbol there, angle 5 and angle 1. And then they share this side. And then the last thing you might be asked would be to name a pair of complementary angles. Remember, complementary angles they don't share, they add up to 90 degrees. So complementary angles, if we look at our picture, we do have an indication of a right angle, and that would be right here. This box is referring to this angle. So the two small angles that make up this right angle would be angle 3 and angle 4. So they would be complementary. We also have a pair of supplementary angles. So remember, supplementary angles, I'm going to abbreviate there, they add up to 180 degrees. So what we're looking for in our picture here are two angles that make up a straight line. So if I look at line AB, are there two smaller angles that make up this straight line? And there are. There's angle 1, which is right here, and then if that continued with angle 5, it would get us back to that line. So supplementary angles would be angle 1 and angle 5. In your workbook, in your textbook, they'll also be asking you problems like this. If you're given this picture, you're told that this whole angle is a right angle. So angle MNP is a right angle. They want to know what is the measure of this little angle. And we have ray O here in the middle. You know that this bigger part of the angle is 68 degrees. Well, because angle MNP, the big angle in this picture, is 90 degrees. And you know that part of that angle is 68 degrees. To find the measure of angle MNO, we would take the full 90-degree angle, subtract the part of it that we know, and that would give us the measure of angle MNO, which is 22 degrees. They might do something similar with a straight angle, so it might look something like this. And let's put some letters in here so we can talk about the angles. Again, this is our unknown. This is what we want to find. We know that this small angle measures 50 degrees. Since we know that angle ABC, the straight line down here, is a straight angle, it has measures of 180 degrees. And we know part of that angle is this angle, this small angle right here, 50 degrees. So if we want to find the measure of angle DBC, which is the missing part of that straight angle, we're looking for the measure of this right here. What we can do is we can say that that's equal to the full straight angle, 180 degrees, and we subtract off the part that we know right here, 50 degrees. And that tells us that the measure of angle DBC is 130 degrees. And one last example. If we have two lines that intersect to form vertical angles, and we call these lines A and C, and then D and E, and then their intersection right here is at point B. And we know that this angle over here is 74 degrees. And we are asking, what is the measure of angle DBC? Well, angle DBC is a vertical angle with this 74-degree angle. They're directly across from each other. And remember, vertical angles are congruent, so they have the same measures. So angle DBC would be 70